Hello, everyone. Thank you so much for attending this presentation. And I'm very happy that Indian Geotechnical Society chapter of Thiruvananthapuram is organizing this international symposium on very important topic, sustainable practices in geotechnical engineering, which is very important topic, very timely topic. So my presentation is on how to incorporate sustainability in design of waste containment systems. Again, I want to thank Indian Geotechnical Society, Thiruvananthapuram chapter, and particularly I want to thank Dr. Krishnan for inviting me to present this webinar. I also want to thank Secretary for IGS Trivandrum chapter, Dr. Jay Mohan, for organizing this conference and making me part of this symposium. I'm from University of Illinois, Chicago, and I'm in charge of these two labs, a Sustainable Engineering Research Lab and Geotechnical Geoenvironmental Engineering Lab. Our research consists of environmental remediation of soils, sediments, groundwater, and stormwater. And our research also consists of waste management and landfill engineering. And recently, we have been doing a lot of work on life cycle assessment and sustainable and resilient engineering. And we also work on geotechnical engineering. So there is a lot of research on all these different topics. If you are interested in knowing more about any of these projects, please feel free to go to my website and you will be able to find more information. Coming back to the presentation, first I want to introduce you to waste containment systems. Basically I'm talking about landfills. And I'm going to first mention about critical design components and what are the minimum design requirements for these critical design components. And then I'm going to show you how we can incorporate sustainability into design of these waste containment system components. So first I want to present a framework, and then I'll show you examples of how we can think about selecting sustainable waste containment components. And then I will make a final remarks. So let's get into the introduction. And many of you may not be familiar with the waste containment systems for municipal solid waste. So what is municipal solid waste? It's any materials, trash, refuse, garbage that you throw away from the homes and small businesses. So it's basically the garbage, that we call it. And as you know, everywhere it is generally collected by governments. You just from the homes and small businesses. And municipal solid waste is different than hazardous waste. So it's generally considered as a non-hazardous. Sometimes you also have industrial waste that is non-hazardous. And then household waste that is non-hazardous is combined together. And so we call it a municipal solid waste. So obviously, it is collected and it needs to be handled properly. Otherwise, this is the municipal solid waste that you are looking at it. I mean, it varies, composition varies from location to location, but it's very important to handle this one. What is the composition of this municipal solid waste that we dispose of, from our homes or, other facilities? So this is the typical composition. You can see that it has some plastics, metals, glass, paper and paperboard, yard trimmings, food, wood, rubber, leather, textiles, and other things. But again, this is the composition in the US, and it varies from country to country, and maybe it may even vary regionally within a country. So in the municipal solid waste in the US, we generate about 267 million tons per year. And that translates to about 4.5 tons per person. And that's a lot. And then what are we doing with this waste that is generated? As you see from here, this is the total waste that is generated. And then it shows, how much is recycled, how much is composting, how much is the combustion with energy recovery, and how much is being landfilled, and what are the other kind of food management options that you're doing. But if you look at this graph, you can see, the landfill portion that you see here, that's more than 50% of the waste. So more than 50% of the waste is going to landfills. And so landfills become very important aspect of the municipal solid waste management. And the landfills are engineered structures, and it has important components that needs to be properly designed. And basically, you have excavation below the ground, and then you construct a bottom liner and the side liner. And then you also have to have a leachate collection and removal system. And then you pile up the waste in layers, compact them. And then once you reach the capacity, you put a final cover. So from engineering point of view, the bottom liner and side liner and leachate collection system and removal system and the final cover are extremely important and should be properly designed. So in the US, we have federal laws and regulations, and they are applicable for landfills. And the main federal law is called Resource Conservation and Recovery Act. And it's a regulatory approach. You have to follow this. And then under this, US EPA has the regulations that require dumps to be closed, and also for new landfills, there are requirements on how to design them. And the states must develop comprehensive management plans. They might have more stringent landfill design requirements. CERCLA or Superfund is another law that addresses abandoned dumps and landfills that pose an imminent risk. So any dump or old landfill that is not being taken care of and it's posing the problem to contamination of the subsurface or surrounding environment, that gets immediate attention to be cleaned up under this law. So Resource Conservation and Recovery Act, as I mentioned, that specifies the minimum requirements for design of landfills. So as you see, this is the cross section that shows the minimum requirements for the liner. So you see the bottom liner and you see the side liner here. And it requires you to have a composite liner. You have to have a clay and the geomembrane. Geomembrane is a thin plastic sheet. And then it shows you the requirements here. The bottom, you should have a low permeability soil with the minimum thickness of 2 feet and permeability of less than 10 to the power minus 7. And the geomembrane on the top has to be a flexible membrane liner, minimum 30 mil thickness. Or if you have a HDPE, then it has to be 60 mil. So that is the composite liner that goes at the bottom and also the side. On the top of the liner system, you have a leachate collection system. And typically, you have a granular leachate collection layer. And then you may have a geotextile filter, and you may have a protective soil layer on the top of it. So I will talk about these components a little bit more in detail later on. But again, as you said, once you put this municipal solid waste, once it reaches the capacity, you put the final cover. Again, the final cover minimum requirements are specified in the law, RECRA. As you see here, you need to have a soil layer, which is called infiltration layer with the hydraulic conductivity of less than 10 to the power of minus 5. Or a minus 7 if you have a low permeability layer at the base. And then you have to have a flexible membrane liner, minimum 20 mils. This consists, and then you have a vegetative soil layer on the top. So basically, this RECRA provides the minimum requirements, but you don't specify these minimum requirements. You do the engineering analysis. And a lot of times these needs to be, minimum thickness may be increased or materials may have to be changed so that, your performance requirements are met. So RECRA provides the minimum requirements, but you do the technical analysis and decide the final, materials and the thicknesses for each of these components. So a lot of times, we just do the technical analysis and recommend the design, but we don't consider the sustainability. So now it is becoming very important to consider the sustainability in addition to your technical design. So you have to combine the technical design and sustainability so that you have a sustainable waste containment system. If you are not familiar with landfill design, I highly recommend you to look at this book. It tells you a lot of details about how you design the liner system, leachate collection system, and the final cover system. So that is the waste containment system that has the components and the minimum requirements. And as I said, you do the technical design, but how do you do the sustainability assessment? Whatever I've designed, is it sustainable? Or are there any other options that you can think about it, or you can optimize the system that you are designing for sustainability? So this is, important. And for this one, you need to think about what is sustainability, right? So this is the broad definition that you see: development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So this is a very generic definition of sustainability, but then you have a functional definitions given by different agencies, and the definition is a little bit longer than the generic definition. But the most important aspect of all the functional definition is this environmental, economic, and social conditions. That is often called triple bottom line. So the concept of sustainability, or the essence of sustainability, is captured by these three aspects. They're often known as three pillars or triple bottom line. So you probably have seen this Venn diagram that shows both environmental, economic, and social. Sustainability is all about optimizing these three elements and maximizing the positives and minimizing the negatives. So that is basically the sustainability. When we want to look at the sustainability, we really need to look at these three dimensions: environmental, economic, and social. And then in order to assess how sustainable your system is, you need to have indicators that can be measured for environmental, economic, and social aspects. And if you have those indicators that are measurable, and if you know those values, you can monitor or you can assess, which one is more sustainable, or what degree your system is is sustainable. So the sustainability indicators have to have metrics, basically, numerical values, and that should be, you should be able to calculate them by using some tools. So the bottom line is, if you talk about sustainability, you need to quantify the sustainability. In order to quantify the sustainability, you need to define the environmental indicators, economic indicators, and social indicators. And then you need to select them so that they can have metrics, or you can express them in numerical values, and you should have tools to calculate them. So for environmental sustainability, you can define the indicators that represent various environmental impacts, So those impacts should be calculated, and these kind of tools can help you. For example, carbon footprint analysis gives you carbon footprint, and the more comprehensive approach is the life cycle assessment that you can use, or streamlined life cycle assessment. And there could be a lot of other tools. Life cycle assessment, LCA, is the most comprehensive tool that is used to assess the environmental sustainability. So remember, a lot of people assume that doing LCA is a sustainability assessment, but this considers only the one aspect of triple bottom line. Economic and social aspects are not considered; those are equally important, and they need to be considered in addition to the environmental sustainability. So this LCA gives you environmental impacts, some indicators and metrics, and you can calculate these things during the entire life cycle of a project, from raw material acquisition, transportation, construction, operations, and so forth. And essentially, in this LCA, you consider what are the materials and energy resources that you are going to need. And then this assessment gives you, consequent waste and emissions, right? So, waste and emissions are basically the environmental impacts. And good thing about this LCA is the method is standardized. So ISO LCA as a standard, ISO 14040, and this is what you have to follow if you are doing the LCA approach. So LCA is defined as the compilation and evaluation of the inputs and outputs and the potential environmental impacts of a product system throughout its life cycle. That's how it, ISO standard defines. So basically, as I mentioned, it takes the materials and energy as the inputs, and then outputs are the environmental impacts, and then you can assess those environmental impacts for sustainability point of view. So this methodology has 4 phases. So these are the phases: goal and scope definition, inventory analysis, impact assessment, and then interpretation of the results. So anybody who does the LCA, they have to follow these 4 phases or 4 steps of this analysis. So I'm not going to go into details of those 4 steps, how you can do it. But the SEMA Pro is one of the softwares that is used to perform this LCA assessment. And in this one, there are different methods of doing the impact assessment. So eco indicator is one of them. This is basically a European method. And Tracy is another method that is developed by US Environmental Protection Agency. So in North America, we use Tracy, and eco indicator 99 is used in European context. So if you are in India, you have to think about which methodology you should use for environmental impact assessment. So that's about environmental indicators and metrics that you can do it. If you have any special tools, you can use those. But if you don't have it, LCA is the most general methodology to calculate environmental indicators. In terms of economic sustainability, so you need to identify the indicators, direct economic costs and benefits, indirect economic costs and benefits. So you need to find out the tools. Often we are not familiar with economic assessments, but you need to get help or you need to learn more. And you can have tools like life cycle costing or cost benefit analysis and so forth. For social sustainability, this is very challenging. This is about how communities or individuals that are affected by the project are going to be impacted. So you need to be very careful about how you select these indicators. And then the problem is you need to be able to quantify it. There are not many tools to quantify this one. One of the tools is social sustainability evaluation matrix, or there could be some other frameworks that, if you have access to, you can use those things. So if you have those triple bottom line indicators and metrics, so the sustainability assessment is all about, calculating for these indicators for your technical design. So you have the technical design that consider the safety and resiliency, and then you subject that technical design to this triple bottom line aspects. So that's basically called sustainability assessment. So considering the environmental impacts and economic impacts and social impacts, and quantifying them through the indicators and metrics. So I know a lot of you may not be familiar with the sustainability assessment. So I highly recommend you to use this reference book so that you can understand the basics, and also various tools on sustainability assessment. So once you have that framework, I want to show how this framework can be used to design sustainable waste containment systems. So I'm going to look at different components of the waste containment system and how you can assess the sustainability of potential options. Now let's look at the first: landfill composite liner systems. Remember, as I told you, the subtitle D is the RECRA, that's the US law. According to that US law, they have minimum requirements. The first one graph here shows that you need to have 2 feet of clay, and then you need to have a geomembrane on the top of it. So that is the minimum requirements. If you want to choose this option, start with this requirement, and then do the performance analysis, and you may want to increase the dimensions of it. Now, this is called prescriptive criteria. But USCPA, also gives you the flexibility to look at alternatives. So they don't specify anything in terms of what you want to use for a liner, but they specify in terms of the performance at the compliance boundary, and in the groundwater, you should not exceed the contaminant concentrations, or you should not have concentrations more than certain allowable limits. So that requires you to, consider whatever design you want and do some transport modeling and calculate the concentrations and show that your liner is performing very well. So because of these things, so you can have a very prescriptive design, or you can have alternative designs. So since regulations allow you to have alternative designs, so you can do the sustainability, apply the sustainability criteria, and select something more sustainable. What I want to show you is examples of liner systems. So for example, this is the most conventional liner system. According to the regulations that you saw, you need to have a compacted clay. For example, I'm looking at 24-inch thick compacted clay. On the top of it is HDPE geomembrane. And then on the top, you have a leachate collection system and landfill waste, right? So this liner here is the composite liner, compacted clay, and geomembrane. So that's how the minimum requirements in the law it says. But you could have alternatives. So instead of compacted clay, can I use the geosynthetic clay liner? It's basically a bentonite sandwiched between geotextiles, and that thin layer of that can be equivalent to 24 inches of compacted clay. On the top, I have a HDPE. So in terms of technical performance, you can demonstrate that these two are equivalent. And alternatively, they say if you don't have a clay that is good, 10 to the power minus 7 centimeter per second, can you use the native soil and add some lime and cement and make sure that soil meets the requirements of 10 to the power minus 7 centimeter per second, and then you can have a HDPE liner. So if you don't have a good clay, you can use whatever the native soil you have. Maybe you can do this ground improvement option and then make it equivalent to good clay, right? So now I'm saying these three options are there. So for three options, if I consider 1 acre of landfill and how much material that you need, you can calculate this. This is often called the inventory. And then you can use the LCA analysis, and then you can calculate the impacts. So you can represent the impacts in different ways. And this is one way. It's called single score echo indicator. So geomembrane and CCL combination, as you see, it has a high impact. More number means more impact. Geomembrane GCL has the least impact. And geomembrane and the soil admixture liner, that's the third option, as intermediate. So you can see from environmental point of view, the most environmentally sustainable option is the geomembrane and the GCL. So this LCA can identify different indicators, and then you can compare these things. So the red is geomembrane and CCL. This green is geomembrane and GCL, and the last one is the geomembrane and soil admixed layers. So on the x-axis, you can see all the different environmental indicators, and this is the relative impact compared to the highest is whatever the one which has the maximum, that is like 100%, and relative to that, you can see. For example, here, the climate change is basically your carbon footprint. So this maximum for CCL, and then for geomembrane GCL is only like about 10% or 10-12% of it. And the geomembrane soil admixture liner is almost 40% of what you would get for geomembrane CCL. So from just a carbon footprint point of view, you can see which one is better. So the same way, you can look at all the other environmental impacts and then see which liner option is better. So all the three liners are performing very well from technically, But from environmental sustainability point of view, you can point out one is better than the other ones. So the one which I mentioned is here is the eco indicator. Here is the Tracy method. So Tracy method is the one which is used in North America. So you will find that consistently same kind of results that you find. Geomembrane GCL is the most environmentally sustainable option. So that's the environmental dimension of sustainability. You need to look at economic sustainability. Here I'm looking at just the cost, how much is the cost for constructing these three options. So you can see for 1 acre of landfill liner construction, geomembrane and GCL costs less compared to the other ones. So geomembrane and GCL system is not only the environmentally sustainable, it's also economically sustainable. For example, then, last dimension is the social sustainability. You look at the social sustainability, you can have a different type of social sustainability assessment system. So this is one which we are using it. So we're looking at what are the impacts to the workers, what are the impact to the consumers, local community, and society. And we have under each of these, you have different impacts. And then, one of the simple ways to quantify them is 0 means no social impact, 1 means negative impact. So if you don't have any negative impact, then it's 0. And if you have some negative impact, you put 1. So you add them up for all these indicators. The one which has a higher number, that means it has more negative impacts. So the one which has a lower number, that is a less negative impact. So again, looking at this one, geomembrane GCL as the lowest number, that means that is the most socially sustainable option. So from environmental point of view, from economic point of view, from social point of view, using the geomembrane and GCL composite liner system is the most sustainable option. So that's how you can look at the different alternatives for composite liner system and select the one that is better. Let's look at other component. Remember, you have a liner system at the bottom, and then on the top you have a leachate collection system. So this is the leachate collection, right? So you have a bottom composite liner, clay and geomembrane, or your alternative, it could be a GCL and geomembrane. And then on the top, leachate collection system you have. In the regulations, it does not say what you have to have, okay? It doesn't prescribe what you should have. What the regulation says is the leachate head must not exceed 1 foot or 12 inches at any time during the life of the landfill. So for this one, so typically what people do is they put a 12-inch layer of granular material on the top of it, on the top of the liner. So when the leachate comes in there, and then you have drainage pipes, and then you collect the leachate and remove it. So if you're not going to exceed more than 12 inches, there is no point in making that thickness more than 12 inches. But the material that you have to use is the granular material, right? So it should be able to drain into the pipes and then, be able to taken out from the landfill. So the granular material that you can use, the drainage material that you can use, you could have a lot of different options. So you could use the gravel, tire sherds, glass cullet, or geocomposite drains. So the question is, all these things have high permeability. All of them meet this requirement of 1 foot. So literally, you can meet the technical criteria, but sustainability point of view, which one is better to use it, right? So this is the drainage layer in the bottom. You see, this bottom is the composite liner, and then you have a drainage layer, municipal solid waste, and then I'm showing the cover on the top of it, in the first figure. But in the second figure, while placing immediately after construction, after placing some waste during the operations, you don't have the entire thickness, you don't have a final cover. And when it rains, it's going to fall on the waste directly. And then you're going to create a lot of leachate, and make sure that your leachate collection system can handle it and not allow, leachate built up more than 1 foot. So for doing that technical assessment, we use the program called HELP. So I'm not going to go into the details of it, but you need to input the hydraulic conductivity of the materials that you're using, gravel, tire shed, glass cullet, and geocomposite. and you have to specify where the location is, and then you simulate what will happen during the operational phase for like 5 years, or after closing after putting the final cover for 100 years, what will happen to the leachate built up at the bottom. So you put all that information and do the analysis, and then our target is to make sure leachate head does not exceed more than 12 inches, so 1 foot. So you can see that whether I use the gravel, tire shed, glass cullet, or geocomposite, my leachate head is always less than 12 inches. So that means I can use any of these materials. Of course, these tire sheds, glass cullet, geocomposites appear to be more efficient in terms of drainage compared to the gravel. Now, okay, so out of these materials, which one I should use from sustainability point of view? So you do the environmental sustainability. Again, we can do the assessment for 1 acre, and you know the exact location of the landfill and what materials you needed, and where are you getting those from. So transportation distances are very important because transportation could cause a lot of environmental emissions. So doing the LCA analysis, you can calculate this environmental impact. And you can see that one, the higher means, it's more negative impact. So geocomposite drainage layer system has a higher value compared to these other systems. So based on that, you can see, which material is more sustainable, right? So majority of the impacts come from fossil fuels during the transportation. So these materials, if we have one of these materials not available at the site, but we have to transport from long distances, then the environmental impacts associated with that one will be higher, not because of the material, because of the transport. So again, you can when you do the LCA assessment, you can quantify all these different environmental indicators, and then you can do the comparison of all of these things for different options that you have. And that you can make the decisions based on that, which one is more sustainable. So that's environmental sustainability. And then second dimension of the triple bottom line is the economic sustainability. So you can, at the minimum, you can calculate the costs associated with this one. But if you want to be more comprehensive, you can look at the indirect costs, indirect benefits, and so forth. But just based on the direct cost comparison, so you can see, the tire sheds is the 32,000, and whereas geocomposite is 19,000. So geocomposite comes out to be cheaper for this one based on the material availability and the transport distances that you have. And the social sustainability, again, using the similar framework that I mentioned for liner systems. So you can say zero, no social impact, no negative impact. If you have some kind of a negative impact, I can put 1. And then you can see the one which has the lower value is the more socially sustainable. So geocomposite drainage drain system seems to be more socially sustainable. So you have the environmental sustainability, social sustainability, and economic sustainability, and you have to make a decision based on those indicators and values. So same thing we can do for the third important component of the waste containment systems, that's the final cover. And as I mentioned, US EPA has the minimum requirements. State could have a different requirement. So you need to know what are the minimum regulatory requirements that you have, right? So where is the location? And then you have to look at the federal regulations, and then also the state regulations, and then you need to meet all those requirements. So that's the minimum requirements. Then you need to think about other options, alternatives. Again, you can do the performance assessment and make sure that the performance is satisfactory no matter which option you are looking at. Technical performance, you cannot compromise it. So here I'm looking at the subtitle D without geomembrane. So we have a waste, we're talking about the cover placed on the top of the landfill, okay? So the waste is placed, and then on the top, I have this 18 inches of thick layer and then erosion layer. So this is the minimum requirements is you have to have these two. Sometimes, you may have to use the geomembrane to reduce the infiltration of the precipitation. So here you have, these two clay layers, but in between you have a geomembrane. And then some cases, you can have just a geomembrane. This is called exposed geomembrane. So obviously you can see this one is a two soil layers. This one is two soil layers with the geomembrane. This one, there are no soil layers, but you just place the geomembrane on the top of it. And there are some cases in the US, you have just the exposed geomembrane liner placed on the on top of the landfills. So these are three possible final cover scenarios in case of in the US conditions for US landfills. And then for if I assume 1 acre of landfill, so for these three systems, what kind of materials that I need, right? And then what is the distance that where they are available and the transportation associated with that one. So you need, the materials and the transport distances, basically that calculates the energy or fuel, and then feed into the LCA, and then you can look at impacts. This is the environmental sustainability eco indicator, as I said, European impact methodology. System 1 is that, and this is system 2 and system 3. So system 3 is just a geomembrane. You're not using any soils. Obviously, that's going to have a low impact. But you can see system 1, system 2. System 2 has a little bit higher impact because you are using the geomembrane, not just the two layers. I mean, intuitively, it makes sense, but you can actually quantify the impacts of this one. So the relative comparison of these different environmental impacts for these three options. Obviously, exposed geomembrane, does not involve, too many materials, too much transportation, and that comes out to be better. And again, in system 2, you have geomembrane as an additional component compared to the system 1. So you see the slightly more impacts. So Tracy, again, is applied for Northern American conditions, impact method. And you can see consistently kind of a similar, results. So that's the environmental sustainability. And you need to look at the economic sustainability. How much is going to cost, right? So if you have a system 1 and system 2, system 2 is more expensive because you have two layers and the geomembrane. And in the third case, you have only geomembrane that comes out to be cheaper. So export geomembrane liner system, if it is possible, for your landfill. It's not always, recommended or possible, but if it is feasible, that comes out to be the best option. So following consistently same kind of approach to look at these different aspects of the sustainability. So now the last one is the social sustainability, again, following the similar framework. And these three systems that you have, what are the negative impacts to the workers or consumers, or local community and society? Then you can see that the system 3 as the lowest number that comes out to be more socially sustainable. There's a lot of research going on in terms of innovative cover systems. So, our research project also involves developing biocovers. Here I'm showing you, there's the soil system, and this is the second option of biocover systems. We did technical assessment, and then we did the environmental sustainability assessment. So obviously, the biocovers which use the compost, and you could use the gravel as the drainage layer within the cover system, compost cover with the tire sheds as the drainage layer. So they have a very low environmental impacts compared to the soil cover, whether you get it offsite or on-site. So if you can, have a compost layer and tire shed as the drainage layer in the final cover system, that's going to be the most environmentally sustainable cover system. So again, economic sustainability, consider all the different materials, transportation, and the costs associated with this one. And there seems to be not much difference between just the soil cover versus biocover system. Again, looking at the social sustainability, biocover seems to be more socially sustainable. So that's how, you can apply that triple bottom line framework for any system that you're looking at it. Recently what we did is we tried to combine those triple bottom line aspects, environmental, social, and economic indicators and metrics, and calculated what is the net sustainability index. So because sometimes may have environmentally one option is better, socially other option is better, or economically some other option is better. So if you have consistently one option is better from environmental, social, so economic, then it's fine. It's a straightforward decision. But when you have a conflicting results for this triple bottom line, then this kind of a framework is important. So we call it Qualix, and that framework is we developed recently. And if you are interested in integrating the resiliency is for effectiveness to the changing climate conditions and consequent environmental, social, and economic impacts. And considering that one, you can calculate all those indicators and then integrate them, and we can calculate so-called resilient sustainability index equalizer. So because of the time, I'm not going to talk about this integration of all these triple bottom line aspects, but I highly recommend you to read these papers that will provide very good information about these recent advances that we made in quantifying the sustainability and resiliency. So I know I have gone really, a little bit quick, but hopefully I have demonstrated how you can do the sustainability assessment and pick the option that is more sustainable. So in closing, I want to mention that you need to look at the technical performance for whatever you are designing, make sure it's safe and meets the requirements. And then you can add on sustainability criteria and make sure that it performs well and also sustainable. And it is a triple bottom line aspect. You can use the LCA for environmental sustainability. That's the methodology is well established. But you may encounter the challenge in performing the economic sustainability and social sustainability assessments. But you really need all the three, environmental, economic, and social, in order to be truly called sustainability assessment. So I showed you, this whole general assessment methodology for the liner systems, leachate drainage media selection, and the final cover system. And balancing these environmental, economic, and social impacts is challenging. That's where you need to do the integrated sustainability assessment, as I mentioned, that we did recently. And one system may be sustainable for a particular project, but that system not necessarily always sustainable. So you really have to look at the site-specific, project-specific conditions, because materials may be available at one site and materials may not be available at another site. You may have to transport from long distances for that particular site. So obviously that going to result in a different sustainability condition. So so you need to do the sustainability assessment for specific project. You cannot generalize, by doing the sustainability assessment for one project and considering the same results for others. So currently sustainability is encouraged but not mandated, but it's highly important and to consider the technical as well as sustainability. So hopefully that gave you some ideas on how to integrate the sustainability in design of the waste containment system. So we have performed a lot of different studies, and you can find more information by contacting me through email, or you connect me through the Twitter, Facebook, LinkedIn, and you can go to these websites. And unfortunately, I'm not joining live to take your questions, but I thank organizers for giving me the opportunity to present. And I want to thank you all for listening to me. And just in closing, I want to mention that we organized a webinar series It's on every Thursday on a different topic related to geo-environmental issues or sustainability and resiliency. Please note down this web link, and you can find more information about upcoming webinars and how you register those things. So those are all free, and you can also get a participation certificate. So I hope to see you this coming Thursday at 9 a.m. Chicago time, which would be 7:30 a.m. in India. So thank you very much. Hopefully, that gave you a good idea about this topic of integrating the sustainability in waste containment systems. Thank you very much, everyone. Bye.